Okay, so the last thing we'll do with this dynamic braking and mechanical time constant is look at a plugged motor and see how it changes the time it takes it to stop. So here's example 5.7, and let me get some switch over here so you can watch me work through this problem. So the problem begins, it says, taking the example we had in 5.6, and instead of dynamic braking, we're using plugging. And so the braking resistor is going to be, instead of 0.2 ohms, it's going to be 0.4 ohms. Okay, so we're going to change that. So 0.4 ohms. And let's see, it's increased to 0.4 ohms so that the initial braking current is the same as before. All right, so he says, what is the initial braking current and braking power? And B, what is the stopping power? Okay, so if we have this connected, in the plugging scheme, then that is the two voltages are going to be added together, right? So E sub O plus E sub S. He told us earlier it was connected to 210 volts, right? So we end up with 420 volts that this resistor is going to see. What is the initial braking current? Okay, a little Ohm's law application here. 420 volts divided by 0.4 ohms, and that gives us a very large current of 1,050 amps. Remember, this is a big motor, you know, so we see these kinds of numbers. Now, so the initial braking power that is seen is going to be this part of the equation, applied voltage, current, and so the initial braking power is 220.5 kilowatts. Okay. Then he says, according to equation 5.9, T sub O has the same value as before. And if we look at all the components of that, we you know, none of that has changed, right? This, and then here again, you know, we've got this, and so everything's the same as before. So this time constant comes out to be 10 seconds. And we know from equation 5.10 that the time taken to plug a motor, or the time taken for plugging this this motor, or stopping time, I guess we'd say, T sub S is 2 times T sub O, or 2 times 10 seconds, or it would take 20 seconds to bring this particular motor to a complete stop by using the plugging method. Okay, so we've about got it covered. Very important curve here somewhere. Where is it? There it is. Make sure you're very familiar with that. That's something I want you to be able to recognize, of course. And then also, now that you've got these sets of equations, you know, we should be able to, you know, quantify these things. And I will tell you, you know, I know sometimes this stuff seems kind of abstract and you know, not really connected to anything real, but these curves really come into play. And as you progress further, and depending on what you end up doing, you can apply this kind of information to programming drives that are connected to motors. So there is some usefulness to this. So anyway, I'll stop there. And then there's a few other things that we're going to look at in this chapter. But basically, I guess we better move on. A lot of other stuff we need to get to. So I'm going to start wrapping up this chapter, and we'll just hit some high spots on the way out of here.